This is our CAD model for our robot. Our piston cylinder will be held on a 45-degree angle on a support. And here's the Arduino, the battery, solenoid, and servo motor. And yeah, for our propulsion mechanism, we'll be using a hopper, as you can see. And yeah, here's the other side of the robot, so you can see the solenoid more clearer. Also, here's a more detailed diagram of everything. Here we verify that the wheel is 16 inches off the ground. And everything is within a 12-inch diameter. And here is our steering mechanism. We are using an Ackerman steering system. And the back wheels are just held on a simple axle.
My name is Sophia Bilbao. I am in charge of the team's electrical components. Here's our wiring diagram and our construction quality. As you can see, it can be flipped upside down with no parts coming undone. Here's my code for the sensor testing. As you can see, rotating the disc will change the value of the magnetometer on the serial monitor. Also for the read switch, when I'm not touching it, it stays open. Then when I click it in, it stays closed. And here's our actuation and power test. As you can see, the servo sweeps back and forth while the solenoid clicks.
For controls, the open loop control had 25 ticks before turn with a turning time of 0.65 seconds. Out of 20 scores, it had a mean score of only 30 points. The hybrid control had 20 ticks before turning with a turning time of 0.2 seconds and a KP of 0.225. This produced very consistent results and had a mean of 125 points. The closed loop control had a KP of 1, a desired position of negative 1.5 and 0 to 4 and 0 to 8.4 and 0, and a target distance of 16 inches. This was the most consistent method and never failed to produce a score other than 100. The control parameters were set to optimal times of 0.1 seconds on and 1 second off. The graph shows the average scores for each control method as well as t-tests between each of the three methods, proving that there is a large difference between the successes of an open loop and the other two methods. It also showed the open loop was not very successful compared to the other methods. The pseudocode starts the piston and counts the time the piston is on. It also takes into consideration the position matrix set by the closed loop control and adjusts the magnetometer heading.